All right. So we know how to write a scientific notation number into standard form, but what if they give a standard form and they say, please go turn it into scientific notation? Well, let's take a look at this story problem. A supercomputer can perform 135 trillion, 300 billion operations per second. Please write this quantity, another word for number, in scientific notation. Here's what I would tell you to do. Zoom in and let's take a look at just this standard form number. It's really long and it's really large. Now, with English, we always read things from the left to the right. So let's always start on the left side. What is the first number that you see that's not 0? Really hoping you said 1. Now, keep going to the right and tell me the very last number that's not 0. 3. Anything that is stuck between your first and last number that's not 0, even if it is a 0, that's going to go along for the ride. What do you mean? The 1353, the first number that's not 0 and the last number that's not 0, and everything that's stuck in the middle between them gets copied right here. Now, this is scientific notation, and we did the whole intro talking about, hey, the decimal has to be after the first number is not 0, right? It can't be a 0 on the front, can't be double digits, so our decimal has to go right here. Now, in order to make it scientific notation, we need to times it by a power of 10, so we're going to write times 10 right here. And the last thing that we have to do is we have to see where the decimal was in the original problem, right? Well, it would have been invisible and it would have been sitting right here. So now we've got to count how many places it needs to move to get here between the 1 and the 3. Why? Because that's where you put the decimal down here. So this is where your decimal was. In fact, you can write it in if you need to. And then I would encourage you for these types of numbers to just use the groups of 3 to help you count. So 3, 6, 9, 12, don't stop here. So we're up to 12, and 12 gets us right here, but then we've got to go 2 more spots, 13, 14. So all we have to do is put a 14 right here. There is one other teeny tiny little thing that I do need to mention though. Since this number is bigger than 1, we're going to use a positive exponent. So let's just put a note right here. If the number is bigger than 1, it'll be a positive exponent. So since this number itself is bigger than 1, it's not about counting the decimal movement. No, 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 no. This is 135 trillion, right? So since that's bigger than 1, this needs to be a positive exponent. Now, let's come down here and do number 2 together under the check. Please write this in scientific notation. No problem. What's the first number not 0? What's the last number not 0? Anything trapped in between those two numbers? Pull those numbers out. Don't forget to put the decimal in the proper place. Times it by 10. Now, let's go look at the very last one for this example, the check question number 3. It's definitely smaller than 1, right? So we've got to use a negative exponent. You might want a quick little note there because it's less than 1, right? What's the first number not 0? And what's the last number that's not 0? Nothing's caught in between the 7 and the 6, and that's fine. And sometimes you only have one number that's not 0. That's fine. So just pull out the 76, put the decimal in the right spot, times by 10. And now we know it's going to be a negative exponent because, again, this number is less than 1. But what you're going to do is you're going to move this decimal, the number of places that it needs to move, to land between the 7 and the 6, again, because that's where it should be. Now this is a little bit easier because they actually showed the decimal, but it is a little weird because you're moving this way, and just don't overthink it. So 1, 2, 3, 4, 5, but you're not done, 6. So it's not going to be positive 6, it's going to be a negative 6. So just put a negative 6 right here for your exponent. And there you go. That's how we turn it into scientific notation when they give us standard form.